Okay. Good morning, everyone. This is Federico Visi from Berlin at the New Practice and Design and Computation Studio at TU Berlin. And so today I'm very happy to introduce our keynote, Shintaro Miyazaki. And Shintaro is since October 2020, a professor in digital media and computation at the Faculty of Humanities and Social Science at the Department of Musicology and Media Studies at Humboldt Universität in Berlin. And between 2014 and 2021, has been a senior researcher at the Institute of Experimental Design and Media Culture of the Academy of Art and Design at the University of Applied Sciences and Arts in northwestern Switzerland. So today's keynote by Shintaro is entitled Endosymbiotic Computation, Unlearning Alpaca plus Why Dissipation is Key. So Shintaro, the floor is yours.
Okay. Yeah, thank you for the invitation. Thank you for the introduction. I'm very happy that I can join in this way. And I think it will be a more informal, maybe. I prepared like 6 pages talk, but it's like an hour, so maybe it would be 3 pages or 4. My background is media studies, but I also studied musicology and philosophy. And I did my PhD on a topic called algorithmics. So I wrote the word algorithm wrongly as a musical rhythm, and was trying to kind of make a point that we also need to listen to computers and computer systems, and that this might help us to understand digital systems and computation. That was 12 years ago or more, and since then I was, like, as Federico said, in the realm of art and design research. And then many things happened. So and then I came here and tried to write a little book about how we can counterbalance digitality. So that's the last book. And this was also already a little bit the question how we can do, for example, things like commoning and sharing of resources, and how we can imagine a new or different society with the help of computation. And in the new project I'm trying to present today, I'm finishing up my manuscript in German first, Endosymbiotic Computation. It's more also about the question of life, but it's still the same question about how we can combine computation and life and commoning. So the book has like 4 parts, sorry, and I go along these 4 parts, or I adapted for example, the Unlearning Alpaca is of course not in the book, but the talk is structured in 4 parts. So first, of course, the question, what is endosymbiosis? And then what is computation? And then the combination. And then how is this related to Unlearning Alpaca? And then the last, why dissipation is key. So it's already everything in the title. So I begin with the argument that in order to really understand what we could do and what is possible, we need to uncompute everything and so to say start from scratch, theoretically, at least. And that is the good thing about theory, right? So you can really try to do that, and so you can do unrealistic things. And I started to look into biology, since we are also living beings, and since society is made of living beings. And at some point rather late, I came across this concept of endosymbiosis. So famously, Lynn Margulis articulated her idea of endosymbiosis in the late 1960s in her article on the origin of mitosing cells, which proposed a hypothesis about the origins of cells with a nucleus and which divide through the process called mitosis, in contrast to bacterial cells, which divide differently. And they have no core DNA. So it's about these cells which have a core and which they are called eukaryotes. And they evolved, this is the theory, from a process they call endosymbiosis, according to this researcher, famous biologist, biochemist, Lynn Margulis. This is a theory from the 1960s. And then this was, of course, very controversial. And in the 90s, the latest, it got kind of confirmed that this is really kind of, at least some part of her theory are kind of true. So endosymbiosis is the process where we can only see the result, which is a cellular component, a compartment, living inside another cell. You can see this here. With a mutual benefit for both. So, and the main thing here is this thing called mitochondrium. So there are two major endosymbiosis processes on living Earth. One led to the integration of bacteria, which were kind of proto-mitochondria. These are these green things, compartments. They generated more ATP from oxygen, water, and other things. And the side product is CO2, right? And this is also called cellular respiration. And the second endosymbiosis led to the situation that most plants have chloroplasts in their cells, and they create ATP from light. And this was a merger of some cyanobacteria, which can do this oxygenic photosynthesis. So they also generate ATP. So anyhow, you might have noticed that ATP is something which is involved. So what is ATP? This is just a very short, I think the only quote for today from a book by biochemist Nick Lane, who wrote many interesting books. And it's from The Vital Question, Why is Life the Way it is? And he writes, I quote, ATP powers a change from one stable state to another, like a flipping switch from up to down. In the case of the protein, the switch is from one stable conformation to another. And to flip it back requires, again, another ATP. So this is really like a kind of a switch thing, molecular, and there is a molecular machinery in our cells. And you can see just a famous animation of this ATP. Nowadays, it's possible to visualize these molecules. And you can see towards the end this kind of nanomachinery, molecular machinery. And yeah, this is just, we need to imagine that these are wobbling and it's very fast. This is the ATP, the elements involved. And so here you see this process where DNA gets copied, or at least taken apart. And for each of these little movements, you need one of these ATP molecules, big molecules. Or maybe even you need two, because you can see 1, 2. And many such processes exist in our body and in all kind of living beings, even before the endosymbiosis. So ATP was even there before, because it's also for the other cells, like the more simple cells, important. So I'm talking about these kind of cells. Maybe we had this in school, right? So this is like the kernel cell, and there's the DNA inside, and then mitochondria. They generate a lot of energy, ATP. And this created this situation that this merger was even kind of beneficial for both. And this is the basic principle of I call, or I kind of recognize, like this endosymbiotic process, because the ATP with this merger, yeah, a lot of ATP was generated, and then the point is also that you cannot, how to say, you cannot accumulate or keep the ATP inside the cell, because otherwise it triggers a kind of a toxic process. It generates oxygen, and oxygen is not so good for the cell. It creates mutations, and so if you block this process, then it gets toxic. And so the thing naturally, or like evolutionary, living cells and eukaryotic cells are then evolved that they always don't stop the process and always share the ATP. And this sharing was very interesting for me as somebody who comes from commoning, or sharing and solidarity oriented kind of processes. So it's not, you cannot accumulate, you need always to share. And this situation creates like attraction for other things which also need ATP. And then this is kind of the point where symbiosis is possible. So, and then you have from these little cells, you have multicellular organisms, which are a little bit bigger. And then you have these little worms, and then fish, and so on. And we are also like multicellular organisms, right? So that's the one part with endosymbiosis, that this principle is very interesting and kind of inspiring for maybe other structures also. And then, of course, for me, it was for computation. So then, what is computation in my kind of theoretical terms? Computation is more like a process I want to see everywhere. So the term comes from computare. Com means together. Putare from Latin, like to arrange, to settle, to value, to esteem, regard, consider, judge, ponder, and to think about. So it's not only kind of calculating, but it's also like to esteem or to consider, ponder about. This is also in the word putare, and you do it together, so it's computation. It's kind of this open definition I'm interested in computation. So computation is to think about something using calculative, algorithmic, or mathematical procedures. So we can find computing within all kinds of processes, which are firstly entangled with knowledge generation, judging, considering, secondly, calculation, arithmetics, mathematics, I already said. Computation is operating with numbers for some purpose, right? And the purpose would be if we combine endosymbiotic purpose. This is, I think I make it short. In English, we differentiate between computing and computation. So computing is rather hardware-oriented processes, machinery, and computation is a bit more open, more abstract, I would say. So in the book, I wrote like some sub-chapters about the history of computation, just to make the point that how kind of narrowed down this computation became, and how kind of tightly coupled it became to capitalism and the execution of powerful extractive operations. I think you are also familiar with these kind of studies and theories. Maybe I just make it quick. So I start with Computos around 1000, so computation. Then back then it was like about the calculation of the Eastern dates. So when is Eastern? And the church was kind of using clever people to calculate this. The problem is with the moon cycle, and that the moon cycle is shifting, and you don't know exactly which date Jesus was kind of how to say crucified. And there's no exact date. There's only this kind of stories around. It was like close to another Jewish day, and this is connected to moon cycles. Anyhow, so this is Computus, which was already kind of entangled with power, church. Then around 1300, we have this kind of influence from the Arabic Indian numbers, and the guy the Arabian scholar who kind of wrote a treatise about using arithmetic numbers is called Algorithmi, and the Latin translation was like Dixit Algorithmi. This guy said, and then this kind of got abbreviated into algorithms. So what we call algorithms nowadays comes from this kind of process, which is like using numbers with our numbers we have with 101 or 1, let's make 104, and then you can write down 105, and then you can do addition, right? And then you have the positions, and all these kind of systems comes from this time. Then we have double entry bookkeeping. It's also an interesting process. The division of computing, which is related to Adam Smith's division of labor. So in around 1800, you have already little manufacturers of calculation where they kind of calculated trigonometric tables in which were used to calculate in cartography to calculate the fields and so on. And then finally, the 5 and 6 is about what we usually talk about when in terms of computation, is the Turing machine, and then of course digitalization and how this kind of developed into our current state, where I used the theory of Mackenzie Walk. She talks about vectorialism nowadays, which is like another layer of which comes to capitalism. I think maybe you're familiar with this theory. Just wanted to mention it. So this is just to make a long point, kind of short, is to that's computation is kind of narrowed down, and let's try to unlearn computation and think what is different, what is possible otherwise. So this idea with the endosymbiotic computation is trying to reglue and repair what has been taken apart. And this is also what I mean a little bit like as a provocation, that this would also involve unlearning Alpaca in terms of algorithmic patterns in the creative arts. So how can we imagine new practices where we use different means of computation? This is also something I would like to discuss maybe with the people here, or just like propose as a question. And in the book, one way to do this, I call is an approach I get inspired from Deleuze-Guattari, minor literature, and I call minor coding or minor programming. So minor is in contrast to major, which is the default hegemonic identitarian, you could say, or fixed, always dogmatic kind of male white supremacist perspective. While minor is always, it's not the opposite approach. It's the opposite, but it's always changing and it's kind of ever fleeing. So to say, so minor cultures and minor approaches are always adapting, critical, and against the mainstream approaches. And I would like to see this also in Alpaca. That's kind of the proposal. So, and this is inspired, just to dive in a little bit more, from Deleuze-Guattari's analysis into Kafka's work, Franz Kafka. Kafka was like writing this kind of counter words or kind of analysis of, for example, bureaucratic problems, right? We also, some of us face, for example, if we go just to the immigration office and so on. So these kind of bureaucratic systems, Kafka was very interested in and tried to analyze. And he created this kind of, using his writing and stories, he created these kind of counter machineries where he proposes different ways to tackle these things. It's not so direct, but at least he shows that it's kind of crazy, right? And in this kind of similar terms, you can apply this kind of idea to to minor programming, which would use, for example, still use major languages like C or Python, whatever, but to create counter words like games or applications, workshops where you, for example, criticize or which are against fascism or which are against this kind of hegemonic structures. So, for example, also minor, you can also use, it has a musical connotation, right? So the minor chord is already diminished and triggers kind of a, in the theory of Deleuze-Guattari, you would call this deterritorialization. And the major chord is kind of fixed and, is stable. So it's about making things unstable and taking apart, but then also putting them together again in a kind of careful way. If you put them together in kind of strong way and make it really freezing, then this is fascism. So this is kind of, in simple terms, the theory Deleuze-Guattari. Of course, you can make them fixed, and stable, like in music. This is important, right? But it's you can always change it a little bit, or you can make a new progression, or you can try it out differently. But if it's like really conservative, the attempt is really to conserve exactly this style or this piece of music, which is, I think, in music never the case, because you always reinterpret it, and like even in classic music, right? And and music also for Deleuze-Guattari is a very important field. So there, if you're interested, you can read Gilles Deleuze, Félix Guattari's work. There are many kind of metaphors or many things which are useful for music signaling aesthetics interested people, like patterns, pattern interested people. So are there like useful examples for this kind of, for my idea of endosymbiotic computation? And this is kind of the question, right? And then I was trying the book, I was trying to find, I was writing about examples from two fields. Very simple, I categorized them with data analysis and modeling. And so new ways to do data analysis, new ways to do modeling. I talked about, or I wrote about, sorry, for example, something like which is called paleogenetics. So archaeogenetics is the kind of analysis of using ancient DNA to which triggered a lot of kind of questions about our humanity, right? So who are these Neanderthals? Are we related to them? Yes, we are related to them. Did they use this and that? And then also another humanoid kind of species appeared, the Denisovanian, and so on. And this was all everything triggered by this paleogenetics, which was kind of using a lot of statistics and a lot of computational methods, but in kind of a simple term, in simple ways. I would say it's so that I categorized it as data analysis, kind of new ways to do unstable or destabilizing usages of data analysis, which then kind of changes the knowledge kind of very fast. Because it was assumed that Neanderthals and Homo sapiens never kind of interbred, and so on. And then the next field is modeling. So I was looking into agent-based modeling, for example, the uses of agent-based modeling in archaeology to change also kind of fixed ideas in archaeology. And agent-based modeling is enabled the researchers to simulate things, and then maybe it was different, and to make a point that it was indeed not as all the people, all the researchers imagined. Then in a little bit connected field is the cellular automata field, artificial life, where it's shown that actually many things are possible. There's a whole virtualities of many possibilities, but the problem is how can we kind of make them real, right? So in the computer, you can do actually, you can simulate artificial life, you can simulate this kind of evolving cellular automata, which kind of behave like, you can program them like as they would behave like they would be Turing complete. That's always what they want. So that it's kind of equivalent to the computer, to the Turing machine. But this is kind of also a dead end because, yeah, it's a question of how to actualize these kind of virtually worlds into something real. That's kind of question of energy and so on. And then I finally turned into a field called companion modeling, which is very interesting. So they use this kind of agent-based modeling, but also other modeling techniques, simulation, in the field of development or kind of ecological questions, and do kind of participatory research with stakeholders, and they use simulation and agent-based modeling techniques. So agent-based modeling is this, which maybe you know with the birds, swarm modeling things. They use this kind of agent-based modeling to analyze their problem, which they have, the ecological issues, and then try to solve them together with those people who are involved in these issues. And this is kind of working quite well at some point, until some point, and this is called, or some French researchers call this approach companion modeling, which I found very inspiring because of Donna Haraway and so on, this companion idea. So these are these two parts, this book chapter, which is like about, yeah, other ways to do computing, but kind of using computing, conventional computing. Then there is also this field called unconventional computing, which is also very interesting. which is like looking into cellular computing, fungal computing, and so on. This is inspired by a guy called Adamatsky, unconventional computing. Here's also the issue is, at least in the next 20 years, it's not so fast realizable because there are some issues like if you have DNA computers, the problem of the DNA is like you need a lot of DNA. This would use a lot of space, for example. Or fungal computing is just very slow. You know, the mushrooms, they calculate very slow. And this is also not useful for the conventional ways to use computation, but maybe just for inspiration, this could be interesting. And then I skipped one part. There is also alternative uses of conventional computing, like slow computing, permaculture computing, and other things where they use current hardware servers to create alternative usages, like, you know, they share servers and this kind of more like free software movement field. But still, this field called permaculture computing, this is also very interesting. You can ask me, or you can write me an email afterwards to get these kind of references. The talk here is kind of reference-free. I'm sorry, but you can always send me an email and ask about where is the source of this. So then the question is for here Alpaca, and also I'm going towards the end. So how we can, if we have this kind of two fields, very simple field, data analysis and modeling, how we can relate this to computer music or pattern generation. So then I thought maybe for the first field, we could look into alternative ways to play back data, sonification, modification, new sonic interpretations, question mark. The second part is about modeling, how we can incorporate modeling into computer music. It is already there, but how you could make it, you could open it up. So it's about the way how an algorithm sounds, how a model sounds maybe, or maybe it's also about how to learn to code this kind of model, which is also important for different ways to use computation. Similar like what I meant with companion modeling, but for sound. So you could do sound workshops, pattern generation workshops, which are not only about generating new patterns or interesting things, but which have kind of a political, agenda, and maybe use kind of this idea of the endosymbiotic computation. So the endosymbiotic computation, just to make it clear, I think it's not yet clear, but it's this process of nesting processes, nesting entangling, using compartments, but then also not just letting them close, but come up with a new compartment which is bigger than the one before. And this process could go on and on because this is, at least if it's a living process, because we have also this principle of dissipation, which we are also part of. So there is the sun, right? And then there is entropy, but living beings are creating order for a short time, but there's always things leaking out and dissipating, and this dissipation is also kind of wanted because the main idea is to go towards entropy, right? Or it's not the idea, it's a principle, a physical principle. So, and living beings are always creating more energy as it's necessary. I'm like, if I'm talking, I'm sweating here, so I'm generating more energy, more dissipating more stuff as it's needed. And also, this is done with music, with concerts, for example. You cannot close up a concert. It's the sound gets out a little bit, and people can also listen from the outside. And so this is also, for me, this is connected to the sharing and to what I call becoming common or becoming mean, becoming medium. In German, it's a bit more obvious. I call it gemein werden. The word gemein has this meaning, this double meaning, and is similar to mean. So you are mean, and the mean value, right? And this is another story how this kind of mean or common gets into this negative connotation. It's related to aristocrats, bourgeois people who just just don't want it to, who just tried to to introduce a counterculture where the exceptional and the aristocrat are kind of the better model, and the common and the mean is just, it's not the way to go, because they were not like that, and so that nobody could kind of tell, how to say, accuse them that they are not common. So for me, this is everything connected, like the commoning and this kind of endosymbiotic process. And this is sort of what is kind of wobbling this cloudy thing called endosymbiotic computation. And also like this idea that we humans, or we can, citizens, we could create try to create the next kind of endosymbiotic merger, not like the top-down merger which we are born into, like the state or the society, which is like something top-down maybe. And one important principle of this endosymbiotic process is that the mitochondrion, the smaller unit, has always the control of the whole thing. So if something in the mitochondria goes wrong, this is very bad for us as living beings. So like we need to build structures which are somehow similar, like this, how this works. And so we would need to make a kind of architecture where the citizen has really the control over the larger, the meta entity. And of course, everybody will say, yeah, this is not going to work, or some will say this is not going to work. And there is also computation is needed to show with models and with games that it might be possible, and to kind of pre-exercise these kind of things. This is what I kind of try to write about in the book Counterdancing Digitality, but it's also still here, like this usage of modeling and computation to make a point. Which is, of course, on the other side, it's always used from the economy or for marketing purposes. There are always models behind their kind of rhetoric. But from the activist, leftist, environmental movements, there are not so many models involved, at least not those which are kind of agent-based models. Of course, I'm like spontaneous now. I'm thinking about that's a little bit wrong, because of course, environmental scientists, they have their large models which show that it's going to not work. But it's a bit too simple model, I would say, and we would need other models which are closer to our daily life and our micro politics. Yeah, that's it. Thanks so far. I have this Blue Sky account. You can contact me, or you can write me an email. And I'm looking forward to the short Q&A. Yeah.
Thank you so much, Shintaro. I'll get, yeah, thanks for that. Oops. So we can have, we can see also our remote guests on there. If there's Alex, Barcelona, here we are. Yes. Okay, great. Yeah, are there any questions?
Comments.
Comments here, and Alex is raising his hand. Alex.
Thank you, Francisco. Yeah, thank you for that really wide-ranging talk, Shintaro. As you were going through the kind of history of our different understanding of computation, I made me think about the fact that history also obviously is a power structure, and people have been calculating things perhaps without writing them down, without it being part of the historical record. And also practices like the Kipu in Andean culture, where things are recorded in notes rather than in writing, and musical algorithms which are embodied and sort of taught through practice rather than written down, and perhaps have less power than score-based music. Yeah, just wondering if you had any thoughts about, and this kind of endosymbiotic thing seems to be a kind of live process where the kind of calculation or the processes are part of the thing that is being sort of described by the DNA. Sorry, not knowing the biological terms. So yeah, I'm just kind of interested in this kind of alternative as something which is live, and also is the actual notation is continually changing as part of that process, whether that's part of this endosymbiotic process that you're describing, the sort of liveness of it, and the lack of separation between the algorithm and the process.
Mm-hmm. The last point I didn't get, but the first, maybe you explain it again. Then so the first point I get, the question about kind of alternative is not the nice word now, right? But otherwise, alternative histories of computation. Sure, yes, this would be another book maybe, or another project to look into each fields where are actually other ways to do computation which are not following this thread I kind of showed. For example, this kind of Latin American indigenous way with the the threads. This might be one. Other forms. Yeah, I would really need to look into kind of the archive, or investigate a little bit more. One thing I described in the book, which I skipped a little bit, is this field where they used agent-based modeling for also simulating, or like for confirming the possibilities of, for example, matrilinear societies, matriarchal societies, or societies, hunter-gatherer societies, where there was a rule to share everything always, and these kind of things, it's difficult to find in the kind of the archaeological record in the material, but you could simulate then and then compare other things. And this is also the usage of agent-based modeling, for example, for this kind of alternative, not history, like prehistory or humanities, history of the humanity. This is something I'm very much interested in. But I skipped the middle part a little bit.
Okay.
So like the middle part from I don't know 5,000 before Christ.
Okay.
But maybe before, so the large story is like, right, is this kind of emergence of agriculture, and how agriculture emerged, and then the change from the hunter-gatherer society into the agricultural society. And then also this kind of shift between nomadic ways and then cities or kind of settlements. And one large settlement, which is very interesting, is Katalhuyuk, or something similar. Is a city in Turkey, which existed. It's one of the oldest cities in the world, and they had houses which, so they had no streets, but it's a gathering of houses, and they were entered through the roof, and in the house there were the people were buried into the ground of the house, and then they tried to, with DNA analysis and so on, they tried to figure out how the people are related and so on, and they are not always related. So not always the family is in the ground, and this is kind of was very interesting for me also. So then the question was how this got organized, and maybe they had like a system where the children were growing up somewhere else other than the family, to maybe reduce this kind of accumulation of wealth, or of power. And this is kind of evolved as kind of a mechanism, an algorithm, in order to have a egalitarian society. So this is very kind of very interesting, and these kind of things are in the history. And of course, you could look more at it, but it's great. We should do more of that.
Yeah. Is it okay if I come back, Francisco?
It's Federico here.
Oh, Federico, sorry.
That's all right.
Sorry, it's still early. So with the Kipu, that reminds me of the IU structures that are the kind of alternative, so to say, structure to the state in Peru and other Andean region in general, I think, where indeed it's not a top-down structure, it's still a tree structure, but decisions come up through family groups. And this is related also to the Kipu, because particularly the sort of pre-Incan civilizations would use the tree structure of the Kipu, I think, to represent these sort of civic structures. And talking with Paola Torres Nuno del Prado, who does a lot of work around the Kipu and electronic arts and things. And also Dave Griffiths, it was interesting connecting that with the structure of Extinction Rebellion, who have a similar kind of, I think they call them rebels or something, and may well be sort of inspired by these other civic structures.
Yes.
With Alpaca, it's interesting to think about how these sort of patterny communities can be dissipated, but also connect together in this sort of bottom-up way, which I think is something really worth exploring as a community of practice. How things can be decentralized but still connected in these networks.
Yeah. With the tree, you mentioned the tree concept. So this was also in ancient DNA one point, that the humanities, maybe it didn't evolve in kind of a tree structure, but it's more like I don't know what they used. It was like I forgot the word, but it's more like something where everything is connected to everything, so it's not rhizomatic, but close to rhizomatic structure. And then there, of course, before the eukaryotic emergence of the eukaryote, the bacteria gene transfer is very chaotic and very non-tree-like.
Yeah. If there are no other questions, I would ask a question, which is actually maybe more like, you know, to elaborate further on this exchange you had with Alex, where you also touched on, you know, ancient societies going from hunter-gatherers to agriculture. So, like, I wonder if you could, perhaps, if you'd like to tell us something regarding like contemporary society and something that perhaps you're seeing through the lens of endosymbiosis, like, so contemporary processes in terms of, you know, algorithmic processes being embedded in contemporary societies, and if you could comment on anything
Mhm.
that you're seeing in contemporary society. Yeah.
Like bad examples or positive
Yeah, I didn't want to, you know, I didn't want to, as it's like influence the your take too much. Like, okay, tell us something bad or something good about
Okay.
it. So, like, I would leave that to you, actually.
I mean, we are always in the thing, in the situation, right? So that's of course I recognize, and of course it's very difficult. But one field would be which is not related to aesthetics, unfortunately, but like financial markets.
Mm-hmm.
It's crazy. What's so crazy? What happens? And it's all algorithmic, right? And it's about digitization and even money or this financial capital nowadays is data and is very detached from material things.
Yeah.
So this is a bad example. But there you could also, since we can do this somehow, since 500 years, maybe this is we could organize this similar to how ATP is organized in life. So instead of accumulating the money, I mean, we just can share it. No? I mean, it's a very simple, stupid idea, but maybe we can. For example, we have tax.
Yeah, tax.
So why not? Really have tax. How to say? Not solidarity. Like rightful tax, right? So that those who, because the rich are not taxed correctly, right?
Yeah, that's evident given the increasing wealth gap.
Yeah, justice, tax justice, what I wanted to say.
Oh, okay.
So, and we could just make some models and show everybody that it's possible and it would have this and this benefit. I mean, this is something like a political party could do very quickly, but it's not used. This kind of modeling is still not used in this kind of context. So this would be a very simple, very first step to use computer models, agent-based models or something, just to show that this could be possible and this would have this and this. Not only just show the numbers, because they are also convincing, but maybe we want to see how it would develop in kind of certain time frame with certain steps. Maybe we can even have a plan and then say, first we introduce this law and then this would happen, and this could be part of a simulation, part of a game, and people could play it or show it. Yeah. So this is one way.
Yeah, that would be the positive, right?
That would be the positive.
Yeah. Thanks.
And then in terms of computer music, it's a question. I mean, music. I like music because it has this dissipative element already in, and it's effective. But it's also dangerous that it's effective, right? You can also use it for other political purposes, but that actually at least you can connect via sounds, via signals very easily. This is the one great point of music.
Yeah, I agree. Music is great.
And it's contagious, and it can spread.
So like you contagious. You see, like also music as a kind of agent for some kind of what would you call it?
Like a kind of thoughtful revolution.
Yeah, yeah.
Right?
Nice. Okay.
Like the rave,
The rave as
counter rave movement. Like
Uh-huh.
when in some years ago, when Brexit was introduced, there was like many raves against this.
Mm-hmm.
But this is the affective part. And in the last book, the one point is that this is, of course, useful, but we should be also careful. And then this idea is to use modeling and software
Yeah.
simulation, the power of computation to get more reflected, more kind of rational and not so just outrageous, like, just not just raging,
Yeah.
raving.
Yeah.
We can do that.
To imagine what happens after the rave, you mean? Like,
yeah, to imagine or to rave in a way that it's not only like, I don't know, disruptive for some people, but maybe it changes things.
Yeah, exactly. Yeah. That's the thing that Zizek often says. I want to see what happens the day after the revolution, right?
Yes, yeah. I mean, revolutions are possible, but the day after the revolution, that's always the problem. And
yeah, exactly. Great, thanks. So, like the book you were referring to is your Counter Dancing Digitality?
Yes.
Yeah. So, Counter Dancing Digitality, I'll do a little promotion for you. It's open access online. You find it if you just use your favorite search engine and type in Shintaro's name and Counter Dancing Digitality, it should definitely come up, and it's open access, so anyone can get a PDF for free. Is that correct?
Yes.
Yes.
And this one will be also, I hope, end of 26 or maybe later in English. An English version is planned. Endosymbiotic computation. Also open access, hopefully.
Great. Thanks so much.
Okay.
There was just a procedural question from Stephanie. Is there a paper for this talk, or is would you like to share a text for this talk, or is it best just to direct people to particular writing you've already published?
You can write me an email. The text is really sort of chaotic, and it's what I read. So I can share this, but it's not really informative, I guess.
Okay.
But yeah, I could. If there is a proceeding or something, I can write it up for.
Yeah, we can publish it as part of that. Yeah, we've got. Yeah, we can do it.
It's a bit too early
I'll
for
write
me,
you
but
about
I could think about. Yeah.
Cool.
Awesome. Thank you so much. Are there any more questions? Yes, actually we have.
Great.
Okay. A very interesting talk, as much as I could understand.
Okay.
You said something about the individual being important, but then again you said that average and mediocrity is like a bourgeois term. You know, you said like mean.
Yes.
It's a bourgeois term, and it has a bad connotation.
Yes. But we should reactivate it.
We should reactivate it, but then the individual.
In a good meaning.
Okay. Why?
Because
you said the cell dies without the mitochondria functioning or something like that. You said that the smallest part is very important.
Yes.
So the individual.
Yeah.
But isn't this a contradiction to the mean? I mean.
Okay. Yeah, but the smallest part, we need to also act. The small parts are acting together.
Yeah.
Somehow, against the larger part. It's not only one. One mitochondria would be have no effect.
It's lonely.
They're very lonely. I mean, there are always many. From the mitochondrial cell, from the eukaryotic cell, there is not only one mitochondria there.
Yeah.
There are like 50 or maybe 200 or even more, and they are also connected to each other somehow. This is like also kind of speculative research or very recent research, but there's a lot of interesting stuff with how the mitochondria connect to each other. So this is then the common.
Yeah. And relating to Federico's question about social algorithms, how do you feel about Spotify?
Spotify is, I don't know, may be useful for some people, but it's pretty clear that
But
it's,
for music, I think it's not that
it's not
beneficial.
bad.
It's not beneficial.
Not
for
beneficial.
music.
No, absolutely no. Of course,
It's
it's within the capitalist
yeah.
apparatus.
And I wish I learned more about. You said something about computer permaculture.
Yes,
Is that a thing? I can research it online. I never
you can
heard
look
of it.
at
Yeah.
either perma-computing or permaculture computing. It's
Okay.
inspired from permaculture, gardening.
Yeah. I know.
And then the idea is how they can import this into computing
Okay, so it's like using the same technology for longer or something like
for
that.
longer, more sustainable, but
Uh-huh.
also repair it, use it, not make a monoculture, not on these kinds.
Okay.
And you can read about there's a series called Counter N and Counter Computing, which is also on my website, but also you can
Okay,
find it.
I will look it up.
YouTube. Counter N is this series I do with Eyül, Osking Eyül Isen, and we have like interviews and conversations with about these kind of combinations.
Okay.
Counter computing, many possibilities.
Thank you once again.
Yeah.
Really interesting stuff.
And this idea with the streaming, there was also there are ideas to do like cooperative streaming platforms, but often they fail because of financial reasons and so on.
Yeah. Well, I thought about Spotify because I just read this morning that Massive Attack just withdrew from Spotify because they're sponsoring something.
There's there are critical books about Spotify.
But for musicians, it's really bad.
Yeah, there's also a book, something in direction of disentangling or dismantling Spotify.
Mm-hmm.
It's published by MIT Press.
Okay.
So, and this is already 10 years old. I think.
Yeah. Okay. Thank you so much.
All right, great.